Howdy, and welcome back to the Pearl Snap podcast. My name is Hal Grebe. I'm the owner and founder of Pearl Snap Consulting Limited. Thanks for joining me today. We'll be talking about a recent post that I shared on LinkedIn about how I fried a complete building automation system. Um, why is this relevant and where are we going from here as a company? Well, I'm glad you asked. We recently partnered with Total Protection Solutions as a dealer here in the Western states. I'm very excited and proud of this opportunity. It's a unique opportunity that lets us offer not just project management, traditional emergency management, planning and preparedness services, and continuity services. It allows us to take a step in the direction of physical hardware to help your critical facilities, EOCs, data centers, 911 communication centers, and all the equipment and resources that you have within your mission critical facilities and buildings. So, what does that have to do with my story today about frying a building's complete automation system? So, first and foremost, what this automation system does, this automation system was a part of a large recreation center that served day to day the students, faculty, and staff for recreation, basketball courts, racquetball, weightlifting, indoor track. You get the general idea. So this building had an addition put on some years ago. This is for me. This is back in the early 20 teens when I was working at this university, and this building automation helped this facility receive LEED accreditation, which is an environmental energy efficiency rating. And this building automation system basically controlled the entire internal climate of the facility. So, as the day would heat up, as the sun would rise, as an example, the blinds would automatically go down to block the sun, maintain temperature flows and temperature ranges. It would evaluate the use of rooms through motion detectors and sensors. If there was no one in that facility, it would kind of start to uh, stop the cooling or heating depending on the time of year. So very advanced system that was computer driven, again, and monitored the entire internal footprint of the building. So big automation system, very pricey automation system. All told, I think it was around six figures with all of the components, programming, all those things. So how the heck did I fry it? Great question. So, as I mentioned, I was, in my time in higher ed, I had the opportunity to work at my alma mater. It was just a great blessing and opportunity to be there. And when I first got there, I was one of the first programs I took on was the shelter management program. So, any new building we would review to see if it needed to be built to EHPA standards for emergency sheltering. So we could bring in a population during a hurricane event or other emergency. They could be sheltered securely. It had minimum ventilation, electrical requirements, and some other building code requirements for engineering purposes that we had to evaluate and deem if it was necessary or not necessary to be built to these specifications. So this building in question and many others, they had retrofits. And so part of my role was to not only train shelter staff and make sure that our plans and processes were evaluated to reality through exercise, design and execution and evaluation, but also make sure that the facilities themselves worked as designed for their engineering standards. And specifically, this meant emergency power testing and evaluation. So, as I mentioned, I took on the program and I started becoming very intentional about designing processes and a schedule that was conducted annually for the test and evaluation of all shelter facilities and critical facilities that served as EOCs, staging areas, or the like. And I would develop an HCEP congruent situation manual, exercise plan, if you will, and then I would conduct an after action improvement plan. So after the first, in the first couple of years when we were evaluating the critical facilities for emergency power, we, I would work with the facility point of contact and then the facilities division, the staff, the professionals that were there on campus to provide for the maintenance, repair, and care for all the facilities for the water, electrical, and structural components that all buildings have. So, it was multi-departmental. It required a lot of scheduling and coordination to make sure we had the staffing and we weren't impacting daily operations for the emergency power testing. And so in the first couple years, we would do the testing, and the way it worked initially was we would come together, we would do the uh, the power emergency power startup. That we'd have the generators kind of queue up, and the way it works. Forgive me, I'm not an electrical engineer. But the way it works in my terms, the Texan in me, the story terms are the power would spin up on the emergency power side. You'd have a transfer switch, and then you'd have the facility draw or the facility load. And then in between there is the switch and a load transfer or a load balancer. And so as the emergency power would stand up, the load balancer would equalize the emergency power to the building required power. And then it would transfer off the grid power into the emergency power once everything, met equilibrium between itself. So this could be either through a manual switch or an automatic transfer switch. So again, the first couple years we would test and evaluate the success of that. Once the emergency power was powering all the facility demands, we would walk the facility and we would evaluate, yes, all of the equipment that should be running off emergency power is or isn't, or why is this computer not working when that's the shelter manager's computer or things like that. So we would do the evaluation, and then in the improvement planning, one of the ideas that kind of came up for me, at least, because again, I'm not an electrical engineer, but I'm an intentionally curious person. So I asked our facilities folks, the load transfer, knowing that we had power coming in and the emergency power raising up and switching from the current grid power to emergency power. My question was, what happens when the emergency power is just cut off, either through a brownout, a blackout, a lightning strike, whatever, you know, whatever it could be. What happens when just the power goes out and we don't have this, nice controlled spin up, balance, and transfer of power? And the answer I got was, we don't know. We've never tested that. We've never evaluated that. And so that was intriguing to me. And I said, well, next year let's do that. Let's make that one of our improvement items that we can evaluate, and let's do what I would call a hard cut from outside of the facility to block off the power with no spinning up of the emergency generator, with no load balancing. Let's just hard cut the incoming power from the grid and evaluate the facility. So again, this was not just a quick, hasty decision. It required a lot of background research to make sure that the where we were going to cut the power wouldn't impact other facilities. We had to make sure that we were very clear in communicating this to the facility, potentially the facility impacted staff, again, staff and students and faculty, and just make sure that we were all aware of any cascading consequences that we may do. So again, took a year, got approvals from all the higher ups, and went to go evaluate this. And we started small with the smaller facility, which was our EOC and the police training room at the time. And then we went through all the critical facilities in 1 year and did a hard cut. So I'm showing some pictures here. We'll have some pictures posted of some of that, because it was a bit nerve wracking. You may see on some of the faces of the facilities that they had not done this before. We had not evaluated this, and so all in all, it was quite successful. We were really able to more meaningfully evaluate. More meaningfully, I don't know if that's a real word. We were able to evaluate more in a more meaningful way. What was a more realistic drill, to use an H-sheep term, of our emergency power. So very happy about that. So again, so what happened? So in that first year when we evaluated the emergency cutoff to the emergency power to evaluate spin-off, a couple of weeks later, after we did those tests or those drills, we had been working on scheduling shelter management classes. And so in the conversation with the rec center's facility facility contact, who also was a shelter manager, trained shelter manager, and would help me co-train and co-instruct. When I was coordinating scheduling with him, he kind of mentioned, "Oh, that date's not going to work. We're having a vendor come in to fix some equipment that went bad." And I was like, "Oh, what happened?" And he's like, "Oh," he kind of slipped up. He kind of didn't mean to tell me that. So there was a long pause, and then he said, "Well, when we did the emergency shut off drill, when we cut the power outside, we walked the venue, walked the facility, everything seemed to be working." He said the one thing that we didn't realize until a day or two later was the entire Leeds building automation system was not working. It was inoperable. And I was like, "Oh my gosh." And I was like, "Well, what's going to happen?" And I started feeling a little bit of that heart quick beating, like, "Oh man, I'm going to be fired. I just cost the university some money and some time and a lot of frustration." And he goes, "Well, we don't know. That's why we're working to schedule the vendor to come out and evaluate what happened, because everything worked as it should. We had a power surge protection. We had the generator spin up, it balanced, everything worked as it should. We're not sure why it broke." And so, long story short, the vendor came, did an evaluation. They were not able at that time to evaluate the reason why the system failed and kind of went inoperable. So they were able to warranty the work and replace the entire system at no charge to the university. What I have learned since then, and why I kind of started with the end in mind, talking about our dealer agreement with the Total Protection Systems, is in our role in emergency management and public safety, we are nothing if not with out our facilities. We need our facilities, our mission critical facilities, to be operable at all times in blue skies and gray. And what I have since learned about electricity, which again, I'm not an electrical engineer or a complete expert, but what I have learned, one of the reasons that system failed, and what I've learned over my years and always testing EOC, emergency power, and our systems and equipment, is that power surge protection is within a limit. And when a surge hits a facility or hits a piece of equipment, a surge protection turns on, if you will, turns on or activates its protection when it hits a certain threshold of electrical surge. So at that threshold, that's when it protects the equipment or the facility at that high level of surge, hence the term surge protection. So within that protected zone, in the day-to-day alternating current, there can still exist millisecond spikes of electrical current that don't reach the threshold of your power surge protection, yet it's still a spike in electricity. And these millisecond micro spikes of electricity, or micro surges, are in technical terms called transients. And transients exist every day. There are, in the electrical field, within the alternating current of a facility, you have constant surges of electricity from big machines turning on and off, such as your power generators, your HVAC systems, coolers, chillers. There's a lot of equipment inside a facility that when it turns on or off, it creates a millisecond of microsurge. And these microsurges, or transients as they're called, they need to go somewhere. And like electricity, like we've all learned since we were little kids, it follows the path of least resistance. And so that least resistance for most electrical transients are computers and microchips and circuit boards that are within all of our electronics that we have day to day. So sure, you may have a surge protector plugged into your computer, and again, that surge protector is going to protect the alternating current from spikes above a certain threshold of voltage. But in the micro spikes, the active monitoring of transients, that doesn't happen day to day unless your facility has been equipped with that kind of equipment, electrical technology. So, all that to say is, I feel very strongly that emergency management, public safety, public health, hospitals, EOCs, dispatch, data centers are critical facilities that sometimes we put in buildings that weren't designed or intended to hold the sensitive, circuit board sensitive equipment that we have in them today. And so, what my hope is, if you're watching this now, is that you evaluate your critical systems, look at the protection, talk to your facility owners or your facilities services division to see if your facilities and your equipment, your elevators even have surge protection and active filtration for transients. Because if not, what I'm trying to be a proponent of is cleaner energy within a facility that has mission critical purposes. And so, if you think about it, you can have two of the same cars, and if you fuel one car with low grade economy type of fuel, and you fuel the other car with high grade, additive rich cleaners, which vehicle do you think over time will degrade and need more maintenance, repair, or more long-term replacement? It's going to be the vehicle with the more low grade fuel. So the higher grade fuel will have less maintenance, longer life, and better dependability over its natural life cycle. And that's what energy does too. That's what electricity does for our facilities. Something I didn't know going into emergency management, something I would have never thought about had I not fried this power system to understand that even within your protected, surge protected equipment, there are these nuisance electricity spikes called transients that can really ruin your day on the worst day already. So if you have questions, let me know. I might bring on one of our industrial engineers who can better explain electricity and energy if you're not familiar with it. Maybe we'll go in a deeper dive. If you have questions about it, contact me. Go to pearlsnapconsulting.com. Would love to talk to you about it. Love to show you some of the technology, maybe go a little bit more in depth or evaluate and talk about your spaces, because this is something that's real. We have data, use cases, and case studies. Academic research shows the existence of transients. And it is just something that I know in my time in emergency management and public safety, it's not something I really put a lot of thought into, but I'm trying to bring more awareness of it, because it is a great way to mitigate and be a cost savings for all the expensive equipment that we already don't have the budget for. All of your monitors, computers, data centers, your sensitive and operational equipment that you need for that worst day. So with that, thanks for watching. Appreciate. Remember to like and subscribe. Follow us on LinkedIn, Pearl Snap Consulting, and see you at the next one. Appreciate you.